Yeah. So yeah, hi, hello everyone. So this is an week two live interactive session. So in this session, we primarily discuss about the classification algorithm, which is an decision tree, and yeah. So in this week we have covered the last part of the appropriate algorithm and the classification task. And in that classification task we specifically studied or learned about the decision tree, right? How we can draw the decision tree and what is the necessity of the decision tree, right? So let us rewind that decision tree and about the classification. Okay. Yeah. So in in the appropriate algorithm or association rules, what we studied in the data, we have a transaction data, and this from this transaction data we are drawing some, or we are inferring some rules from the data, right? So suppose I buy these items, this much of the items like milk, bread, and egg, and what is the association? What is the what the next product has been bought, right? So this association rules we are getting from the original data that transaction has been already done, right? So these are rules already existing in the data. Those rules are not trivially we can extract from the data. We have to do some task. We have to do some. We have done that finding the methodology. We have created a function that will calculate support and confidence. And based on this support and confidence, we will get as an particular rules. Right. The rules are many items, many transactions has been done, right? So there are millions of the transactions. From this million of transactions we can extract, or we can draw some rules which has already done in the previous transactions. So these rules will help to in the marketplace. Let's consider as an application that is an market transaction, that cart has been we have decided create considered, right? So there is a market store, and in that market store there is an multiple transactions has been done, multiple products has been bought in the combinations by the persons, right? So by millions of the transactions, we are extracting some important rules, important associations. Suppose these products has been bought by a person or customer. So there is an associated another item is also there. So maybe that in the next time or another time that particular product is also bought, right? So these all the things we are discussing here, which is or in the association rules, which are based on the historical data, which is already existing rules we are discussing. So if there is a one customer which is new in the market, right, let's take as one scenario, a case study. If a one customer is come to the that particular market and he bought some combinations of the items which are not previously bought. Means suppose he bought as an milk with the charger, mobile charger, or any other noodles. So this combination has previously not has been done. So in this case, the association rule, the confidence score, or the confidence score of the new item bought by the particular person is very less. It's what I'm saying. I will write here so that you can understand easily. Suppose a new person customer is came to the market, right? So and he bought three items, three combinations of the item, which is an milk and battery, mobile battery, and the noodles, right? So these three we can say it is a diverse and which has been not bought previous data. We have a previous millions of the transactions has done, right? So this three combination has not incident in these transactions, right? So in this case, the association, suppose the association between the mobile and the sorry milk and the battery to the these noodles is very less, and confidence also is very less, because the confidence and support which is calculated or which is generated by existing data, right? Existing millions of the data, and in this existing data, the frequency of or occurrences of this milk and the battery is very less, right? So in this case, it is not uh, a proper way to get as an associated value, or recommend a particular value, right? So in this case, so we are talking about right now the prediction. Suppose the milk, the particular customer has bought as an milk and the battery. Along with this, what next product he can buy, right? So this in this scenario, the prediction comes into the picture. So, but you can fit the association rule in this task, so that may fail, right? That is a failing that we have discussed here, that this combination has been not discovered or not we have seen in the previous transaction. So so that it is difficult to or it is difficult to get as an next or likelihood of next item, right? So to resolve this problem, uh, there is another concept, that is a classification task. So in this classification task, we are trying to predict, using the historical data, we are trying to predict unseen pattern. Suppose unseen patterns, this is an unseen example, right? That a mobile bank and a mobile battery and the noodles. This is an unseen combinations of the item set that has not seen in the previous data. So what prediction or classification task we are doing here? We are learning from the historical data, whatever we have. And from this historical data, that particular function we are building, that learning means we are building a function that learns the historical data and try to guess that, try to predict that what could be the next item that particular new person can buy, right? So let's discuss about the what is the multiple. This is the classification is a task, is a machine learning task we can say, and it is also data mining task we are doing here. And so the classification task, it is used for many applications. So right now we have discussed this classification of predictive task. We can also call this for classification as a predictive task as well. So this classification task we have discussed for the recommendation purpose or the for the prediction purpose. For this combination of items has been bought by the user, what is the next item he or she can buy the next time, right? So this can be also done, right? Suppose you have three classes. uh, let's take as an uh, we have let's take as an milk, battery and the noodles, right? So here noodles we are trying to, we have two combinations, mobile milk, battery and the noodles, and along with the noodles there is an egg and let's take as and egg or what we can say, bread, right? So the along in between these three items, what could be the likelihood of the user he or she can buy, right, from these three items? So it is an list in this in this scenario, it is considered as an, this is an class 1 or category 1, category 2, category 4, like this way. This is a one example I'm trying to map in the previous from our previous discussion, so that's why I have taken this example. So let's take an example of the classification that could be easy to understand. So let's take as an, suppose you have multiple emails you are getting, right? So we need to there is an, we need to classify that, or we need to predict that particular email is an spam email or not spam email, right? Spam or not spam email. Based on that, we need to categorize that. And right now, the Google is Gmail is also using that the spam detection algorithm, right? That is automatically whatever the email comes into the inbox, that is automatically detected it is a normal or a genuine email, or it is a spam email. If it is a spam email, it goes to the spam box, right? So likewise, it is an detection task has been done. Another is, and let's take as an the social media, and you have a multiple posts are there, right? The post one, the post two, Instagram or Twitter tweets, you tweet one, tweet three, likewise. Okay, so these are the posts. And as we know, in the social media there are multiple many peoples, or some peoples are posting an offensive tweets, or it is an toxic tweets, hate speech tweets. So we have to label it, or we have to predict that particular post is an aggressive post. Aggressive means it is an broader term, it includes the hate speech to offensive languages. So it is an aggressive post, or it is non-aggressive post, right? Likewise, it is aggressive post, it is non-aggressive post. So based on that, uh, we can filter it out, uh, the the post, and so that will be help to reduce the mental harassment on the social media, right? Likewise, another example, so this is about I have discussed text data, maybe in this multimedia, the social media post, which is an multimodal means it has an multiple modalities are there, which are the image, along with the image there are text as well there. So it is processing both together and trying to identify from that particular post, it is from which class, right? So let's take as an another example. Let's from the another domain, which is a medical domain. Okay, and from the medical domain, you have multiple X-rays are there, right? Multiple X-rays are there. So from this X-ray, and so from this X-ray, we need to classify. We need to predict that which X-ray it is an cancer patient X-ray. It is an cancer, or it is a non-cancer. But it is an cancer, not cancer. Only need to pass the image to the machine, right? uh, in our function that we can build to classify it is an uh, cancer or not cancer, right? So so the cancer has an there are different patterns in the X-ray, that is a chest X-ray is there, right? The different patterns in the chest X-ray for the cancer patient, non-cancer patient, there is a no abnormal activities has been done in that particular uh, X-ray. Likewise, in the aggressive, non-aggressive post as well, there are some patterns in the aggressive and non-aggressive post. So how the users are writing the aggressive post, they are using many explanatory marks, many aggressive emojis. Likewise, okay. So that and also in spam as well, you can see by watching yourself as well, by human, we can observe how the spam message look like and how the normal message look like, right? So in the spam, there is a multiple capital keywords are using there, right? So these are the multiple patterns is learning the function and trying to do the prediction task, right? So these are the applications. So it's not limited to this these application that we have discussed here. There are a lot of applications are there to do the classification task. So actually, the classification task is a supervised task. Actually, supervised algorithm. It is categorized into supervised algorithm. So right now, so what is an supervised? Right? So in there are learning, supervised learning, unsupervised learning. There are two and reinforcement learning. There are three types of the learning are there. So here, what we are trying to do. So let's take. So this concept comes from our human behavior actually. So you might be observed that there is suppose small child, and the child is that doesn't know how the apple look likes, or how for which vehicle we need to call, it is a truck or it is car or it is a bicycle, right? So we are trying to teach him that is an the red colored, this is an one apple, so we are showing him, right, this is apple, this is an uh, this vehicle is an truck, this vehicle is an car, we are showing to that particular child, and he's trying to learn that, he's trying to capture that, right. So based on this phenomena, based on this philosophy, it comes to into this classification, comes into this learning task actually. So in the, I already said in the learning, there are three types are there: supervised learning, unsupervised learning, and reinforcement learning. So I will give some overview of these things. So we have to discuss about the decision tree in detail, because this week is about the decision tree. But before that, the clarifying this learning and classification task, that is a very important. The motivation behind this uh, classification or different applications of this classification, uh, understanding these things are very important. Right? So as I already said, the learning, there are three types of the learning has been done, can be done. That is an supervised learning, unsupervised learning, and reinforcement learning. So unsupervised learning, let's take this example. These are the record table. In our data mining language, we are calling as a table as a record. The record table consists of multiple attributes, right? So the one from this one of the attributes means columns, right? Attributes columns, and these are the objects. So one of these attributes is represented as a final label, right? So here we have two attributes in this spam detection class, spam detection task. So the first one is an text SMS, right? Text SMS, and it is an label of particular text. This particular message is a spam or not, like this way. This particular message is an spam, not spam, or spam or not, that particular label. So this type of the data we are calling as an supervised, uh, means by using this data we are doing a classification task. So to deal with this data, it is comes into the supervised learning task. Okay, one second. Supervised learning task. So this is a so I have given example to understand the what exactly the supervised learning is, right? So this is a one type of supervised. Whatever we have discussed here, the aggressive, non-aggressive, it is also comes into the supervised learning task, and this is an cancer, non-cancer as well. Right? So it has the data has an label associated. It is and comes into the supervised learning, right? So we are doing a classification task using this historical data, already labeled the data, and we're trying to learn the a machine, trying to learn a function that will used to classify or predict new instances, classify in certain classes, and those classes is already mentioned in the historical data. Okay, so let's discuss about the what is an unsupervised learning, right? So if you have a multiple, let's take as an you have an animal data, and you have a tiger and cheetahs and elephants, right? And you have a cat, a dog, right? And let's take as and what another, these are the two things, right? So here we don't uh, actually this is are the we don't have uh, we have a labels, we have associated categories, but these are the not that labels we are trying to find out. Here we need to find out, our task is to which one is an forest animal which are living in the forest, and which are the uh, living in the we are their pet, maybe the pet of the pet animals, right? Like this way. So based on the cat attributes of the each of these animal, we are trying to segregate them, right? So these attributes of this the cat is, we have a list of the cat attribute, what is the eye color and living, and what that cat particular eat, like this way. The based on this we have their attributes. Based on these attributes, we are trying to segregate them. Okay, so this is a one example. So there are a lot of examples are there. Maybe let's take as an another or mm, let's take as an this uh, social media post, the same example. Okay, okay, social media post, the post 1, post 2, post 3, post 4, right? The post 1, post 2, post 3, post 4, right? So this each post we does not have their associated label. So the labels means it is uh, the label are my. So here suppose I'm taking as an aggressive, aggressive, non-aggressive. So this label is associated to a particular task, that is an aggressive, non-aggressive. Suppose I have created it is an spam, or it is an fake. That label, the particular post is an fake or not fake. So it is, this labels is associated or designed to for a specific task. That specific task is an fake post detection, right? So these are based on the application, these labels are different. So here, let's forget about this. Uh, let's forget about these labels. Only we have a post. Okay, P1, P2 up to the Pn, and in this post we need to identify that from this post only. We don't have associated labels. We need to add which topics has been discussed uh, in this post. So this also comes into the unsupervised task. Okay, so we need to map into the so let's take as an we need to map into the latent space. That is, an latent space means it is an vector space. Okay, so but the P1 is discussed in at this point, P2 is discussed at this, and some Pn, P4, P8 discuss at this point. So these are discussing about, let's take as an about the Mahakumbh. These post only discussing about the Mahakumbh, because which is represented at this point. So the methodology, so you might be confused about how this mapped here, right? So there is an different algorithms, different clustering techniques are there. This comes into the clustering or also a topic modeling task as well. Okay, so this is the this is the way we are the way we can do or let's take as in this post are discussing uh, uh, about the election, right? Likewise, so the clustering is actually the we need to group the data based on their similarities with each other. Okay, so we are grouping this data because they are discussing about the Mahakumbh Kumbh only, and we are grouping this data which is only discussing about the Delhi elections about, right? So this is about the clustering. Reinforcement learning means, suppose you did a classification task. So here very, so might be we are going out of the track actually, but it is might be necessary to discuss these primary things before the we are going ahead in detail about the particular DC classification algorithms. So let's take as an we have algorithm, we have a model, machine learning model, and we are giving a cat image to this machine, and machine has detected it is a dog. Okay, it is an misclassified, it did the wrong prediction. So in this case we are giving a reward, it is and you did a wrong, and then he after getting a reward uh, from this feed forward, I mean, this is feedback we are giving, right? This is an prediction he's done, and we are passing back to the feedback to this model. You have done a wrong prediction. So based on this feedback, it learns and it's try to correct his prediction. That is an cat. So this comes into the reinforcement learning. In the one go, it learns on the experience actually. So like our chat GPT learns, right? So whatever we are trying to, it learns more and more how much you are using, right? So it is a in chat GPT, you also might see there is a like or dislike. Okay, So if it is like that, is a positive reward has been goes to the model machine learning, that chat gpt, and it is it helps to learn more efficiently, right? Likewise, so here right now we are discussing about the classification task which comes into the supervised learning, right. I hope you guys understood what exactly the supervised learning, only the overview, supervised learning and what is an unsupervised learning, what is an reinforcement learning, right? Yes, is there any doubt? Yes, anyone? Or if you have not understood, please let me know. I will give a simple example and try to explain it again. Yes, anyone? Yeah. Okay. Uh, yeah. So where we are also discuss about the applications of the classification task as usual. Okay, let's come to the our decision tree. So decision tree also includes the rules. It learns the rules from the historical data and uh, try to predict a label label or category based on the historical data. So suppose, let's take one example, that is an the same example has been taken, which is an in the Dr. Pabitra has taken the example, which is an the weather is an outlook is an sunny, and it is an rainy, then that particular player will goes to run or play goes to playing tennis or not, right? So let's have discuss this example maybe, right? Or yeah, let's take this example. So here the two attributes are there, that is and this GPA and studied, and based on this GPA and studied, these are the target label, that is and this a student 1, a student 2, student 3, student 4. So here we are only discussing about the decision tree. What is the intuition of the decision tree? We are discussing only the overview of the decision tree here. And student 5 likewise. For the student 1, the GPA is then very low, and he studied he has studied not, the false means it's not studied, and T means it is and he studied for the exam. Okay, and based on this, it is these are the labels, it is an passed or not. The F means it is fail, and T means it is passed, right? So here that the decision tree from this analyzing this data, it is trying to create a tree. Means let's take as an one example, that particular so if GPA is equal to low. Okay, GPA is equal to low, then it is passed or not, right? It is failed, it is passed somewhere, right? Some it is high, it is high means it is uh, passed, and medium it is and fail, or it is um, failed or passed, right? And if it is studied, then it is also the studied, then you can see there are multiple, the fail, it is not studied, then it is passed, failed, it is studied, it is passed, it is failed, then it is not studied, it is failed, right? So maybe let's take as an, so based on this data right now, here we are doing the manual task, right? So based on this, which attributes are more, suppose the studied, if it is studied fail, means it is studied is that particular student is not studied, then what is the chances of the he will get a passed or fail, right? Here we are doing a manual task, actually trying to find the patterns from the data. Okay, so let's take as one our that it isn't studied or not, right? If it is studied, there is an he there are two categories. Is it is failed to study or it is studied, right? So if it is failed to study, so how much time he means, how many students has failed? One, two, one, two. Two students are failed. Two students are failed, and one student is passed, right? Let's take as an if that particular, if the students are studied, then how many times, how many students are passed here, right? So here the it is passed, here it is passed, here it is passed, right? So in three times student is passed here. So directly it is an past student, it is an T, three student directly. This is an a node. So here the tree represents a node and the edges, right? So the each nodes are means they're following ages actually. So there is subsequent. So this is an parent node and these are the child nodes likewise, right? There are here only binary categories are there. That's why only the two branches are there. But if, in many cases here in the GPA, you can say see there are three categories. In these three branches, maybe four, right? So here it is not clearly classified actually. If it is that students are studied, then as they got as an past actually here. So it is an T. There is no further we need to draw anything. So if it is failed to study, then there are three combinations are there. I mean, many students are failed and many students, some students are passed as well. We are confused here to decide, right? We have to take a decision here. Let's understand here. Suppose we need to decide that a particular some students are studied, and what is the how many means what is the probability he will get a passed, or what is the chances of he will get a passed, right? We need to take a decision actually. And if it is failed to study, then what is the then how we can take a decision if it is failed or if it is an passed, right? So here if that particular student is studied, then it is already passed, right? That we have taken a decision from the we can take decision from this already uh, uh, transaction data, means already historical data, right? So here then we have to see the gpa. Let's take as gpa. So in the gpa also there are three variables are there, right? How many? The low, medium, and low, medium, and high. So this low, medium, high, these are the age labels are there. Age labels. These are the age type. Okay, here. These are the age type: low GPA, high GPA, medium GPA, and high GPA. Right. So here, for at the time of the low GPA, how many times students are passed and failed? That we need to calculate here. So if it is low, thus you can see here, if it is low, the students are means we need to see the two categories here. You can see here, the studied is fail and it is low. Likewise, the studied is fail and means it is not studied, and what is the low? So at that time it is fail. So one failed, sorry, one only. So it is one. Means it isn't failed. It is low. GPA is low. And if the medium and the fail is there, at that time also it is failed. And if the studied is F and and the GPA is high, at that time it is an true. You can see true. If it is GPA high and if it's not studied, then it at that time it will get a passed actually. So here you can observe here the internal node represents an attributes. So here the attribute GPA is attribute, studied is attribute. The three attributes are there. From this three attribute, there is an one attribute is an labeled attribute, target attribute, that we need to predict that particular attribute actually. by using this GPA and studied. So this GPA and studied in the decision tree, always they are going to be a internal nodes, and the leaf nodes are the target labels, target values are there. Target values, what are the target values are there? Target attribute here is in past, and in that past at target attribute there are two values are there, if it is fail or it is past, right? So here the leap nodes are the the past or not past. So you can draw rules here, or you can take a decision, you get your any combinations. That combination is already if it is not exist in the historical data, then also this decision tree try to predict on that particular uh, combination, that particular rule actually. Suppose the any student has studied, then he will get he will get a passed. Okay. If any student has not studied and their GPA is high, then he will get a passed. Right. So how I'm taking the decision? So based on this historical data, I try to I draw a decision tree, and based on this tree, I can resolve any such mm, uh, rules, any such prediction for any combinations. Means study, if it is failed to study and he has a GPA low, then he will get a fail, right? If it is a medium GPA, so medium GPA, and if it is not fail, it is a fail, right? So like this way, we are drawing a decision tree here actually. Okay. So you might be think that why you have considered the studied attribute first? Why not you have taken the GPA first, right? So there are the concept comes into the picture, which is an purity. So here, this node is an pure. This node is also pure or not. Let's take as an pure. How we can calculate, consider pure means here the three passed and there is a zero fail is there. Zero number of fail candidates are there, right? In this node, the GPA is high. You can see GPA is high. There are two number of past user and zero numbers of failed student. So this is also pure node. We are calling the pure node when the node has only categorizing a single value. Here only categorizing single value. Let's see this value. The GPA is medium. In that case, how many fail and passed? One F and one T. That means one F, one T. So this is a impure nodes. Impure. It is not pure nodes. It is not a classifying, or it is not a uh, giving a single value. Right. Here also one F and one T. This is also impure nodes. So this, based on this impurity purity, we have to decide that particular node is an pure node, and we have to decide this attributes that comes into the another part. But we need to first see that particular node is an pure node, not pure. This is a one uh, condition. Purity check. Purity check. So how we are checking the purity, let's discuss in further, right? Another is, after purity check, then we have to discuss which attribute we need to consider first as a root node to be splitted. So it needs to take a GPA first, or needs to take a studied first, right? There might be multiple attributes are there. Up to suppose here the only attributes are the GPA and studied, but in many cases, many applications, there are multiple attributes are there, 1 to 10, right? So we have to get a their importance, their how much information gain we are getting by splitting this particular attribute firstly, right? So this is an information gain we are calculating for each of the attribute. And if then based on this information gain, we are ranking the attributes, and which one is a ranked one, that we are splitting the first one likewise. So here you might be think about how we are calculating the purity of the node. Purity means if it is purely purely classifying and predicting a value or not. So there is an entropy. There are two measures are there for checking the purity: the entropy and Gini index. The purity check is an using entropy and Gini index, right? So an information entropy, information gain, which is already we have discussed how we are calculating entropy of studied, right, minus the entropy of their the category one positive, let's take as in positive, and entropy of negative split. So let's discuss this purity and entropy in detail in while solving the question here. Okay, I hope you guys understood how we are drawing the decision tree, and how we are calculating the how means what is the method or to decide the which attribute we need to split first, and how we decide that particular node is it pure or not pure, right? So this is how we are calculating. Also we can uh, represent this decision tree in a uh, that rule based actually. So whatever comes into the internal, which are the and operation, means if studied, likewise if studied is exactly equal to uh, t, or let's take a, if studied is equal to f, and study is equal to f, here we are, and gpa is equal to low, then it is 1f, then f, let's take it as 1f, or that is 1f and 1t. Okay, if studied is equal to f and gpa is equal to m, then it is f, 1f and 1t, like this way. So this is how we can also write in a rule based way actually. Okay, I hope you guys understood. If you have any doubts, please let me know here. Okay, let's come through the questions. So what is the answer for this question? It's very simple. Is anyone? What could be the answer for this question? Decision tree can be used to build models for, we have classification algorithms, right? C. So this decision tree, it is also it is used for classification, that we have also that we have decided, that we have discussed here. And this decision tree also used for regression task as well. Regression task, he means, here we are in the classification, we are trying to predict a particular category, right? The regression task, it is, and we are predicting a particular decimal values, or we can say continuous values are there. These are the categorical values, and these are the continuous values trying to predict. Let's take as an what could be the uh, suppose you have a product attributes are there, and the time t1 t2 3 are there, and you each of the time you have a cost actually, what is the product cost on there. So these are the cost means product price, right? So you are using this data and trying to predict what could be the cost in the next frame, next time, right? So this comes into the regression task actually. So for this regression task, this decision tree is also useful. That is, and based on so it is, and for each of the leaf node there, it draws a line actually. It is line equation, and based on this line, it is trying to predict that what could be the uh, uh, regressor or continuous value, or values are there. So it is used for both of the task, the regression as well as the classification problem. So is there any doubt in question 1? Okay. So see, hmm. So the hyperplane comes into the SVM part actually, that is a support vector machine. So in that, the hyperplane, which is used for the classification as well and the regression as well in the SVM. So yeah, so we'll discuss in further slides. Okay, but here, so in the question 2, what is the answer? Entropy value, entropy value of dot dot represents that the data sample is pure or homogeneous. Pure means that we have already discussed. Pure means on that particular leaf node is only categorizing or only has the single values or single categories. It is, there is no, suppose it is a positive negative, only the positive values are there in the leaf node, there is a no negative values are there. So let's consider entropy, how the entropy values are there. So we have already discussed the what is a pure node. The pure node, that means suppose you have a category studied, right? And it's studied, there is an two values, based on these two values we have split it, which is uh, a false and a true. Based on these two values we have split it, and after splitting, how much we are getting here, let's take as an, here 9 is an false and 3 is an true. These 9 and 3, these are the means, these are the studied or not. 9 are failed and 3 are the past. These values are represented. Okay, here the 3, let's take as an 2, are the uh, 2 are the past. While splitting on the true of the study, then we are getting as an uh, 2 students are passed and 0 as an mm, failed, if they are studied. Okay, if they are failed to study, then 9 students are failed and 1 student is passed. So this is the splitting. So here, by observing this, you can easily, we can easily say that, we easily say that this is an, this node is an pure node, pure node, right? So how we need to quantify as well, right? That is, by human we are analyzing, watching these values, and then we are directly saying that yeah, it is a pure node. But we have to quantify that by using the entropy. As already said, the purity is quantified by entropy, right? As we have entropy and Gini index, right? So how we are calculating the entropy? Let's consider this is S1 S, and this is an S1, and this is an S2. This is split 1, split 2. Okay, let's calculate split 2 entropy. The split 2, how we are calculating the split 2 entropy? Entropy of S1 S2 is equal to probability, here T and P is there, minus probability of, T log of base 2 of probability of T, minus probability of fail to study, log of base 2 probability of F, right? Here you can put these values, that is an 2 divided by 2 log to the base 2 divided by 2 minus, and here uh, 0 0 divided by 0 divided by 2, likewise. So by calculating this, you can calculate it on your laptop, that is, and this is one, and by using this log 1, which is an let's take what log 1 which is an getting 1 second. log 1 is n minus 1, right? So yeah, so based on this, we will get is an entropy value, which is an uh, homogeneous, which is an 0 here. Okay. So how we are calculating here? The probability is point. Oh, how we are calculated it? 2. So 2 plus. Oh, sorry. So here only 2 and f is 1, right? F is 0, right? So here we are getting 0 and with the 0, right? Yeah, into 0. Are you getting? So you can calculate that this will give 0, and this is 1, and this is an 0. So from this you will get as an 0. That is an B. Option B is correct here. That is the entropy for the pure node, which gets as an 0 entropy. So what about okay, let's see the next question. So from that next question we'll try to draw a entropy on this probability changing. Based on this probability, how the entropy is varying. Okay, yes, is there any doubt? Yeah, B option is correct. Okay, let's move to the another question. So moving towards another, so let's see so if there is an 50-50% split, 50 means, let's take as an this node, and as the previous example, that is an suppose 9f and 3t, and here after splitting it by f t, splitting it by f, we are getting as an 5f and 3t. Sorry, one second. 3, it is in 5t, because it is an we have considered this question as a 50-50 as an 5f and 50 is an 5t, right? So after f, the 10 samples comes into this split actually, right? From these 10 samples, only 5 are f and 5 are the t. The 5 are the students failed and 5 students are the failed, right? So here how we are calculating entropy for this node S1. The entropy of S1 is equal to right, S1 is equal to, suppose minus P is equal to T log of to the previous example, that previous formula, that similar that we are using here, F and log to the base and F, right? Here PT we are using the probability of PT, how we are calculating here, which is and 5 divided by 10, 5 plus 5, right? And log of 5 divided by 10 minus uh, minus 5 divided by 10, because 5 is the f is also 5, right? The log of to 5 divided by 10, right? So this is the formula we are using here. And what is the answer for this equation? Yeah. So this is a zero point 0.5 minus, and so here we are getting as a minus 1 from the log of zero point 0.5 log 1, and then it is in 0.5, and we are getting as an log here, which is an minus minus point sorry, minus 1, minus 1. So my handwriting is mistake as an is point right, minus 1. Yeah, yes, I hope you guys understood. The entropy you will get 1, right? Please calculate it here. So 5 divided by 10 is an zero point 0.5, and 0.5 log to the base 2 is an minus 1, right?
Yes.
Yeah. So here let's see how these values are changing over the graph actually. So let's take as an here that is entropy, right? Is and the probability of the true and the probability of the false maybe here. As we have saw here that for uh, what we can say for entropy 1, here the entropy 1 we are getting as an 50-50% as an split, that probability is in zero point 0.5, right? So here zero point 0.5 we are getting this value at entropy, at one entropy is equal to 1. And for the zero entropy we are getting as an probability of true and false is an that pure node, that is an 1 maybe, right? So here you can see like this way the plot is getting from the entropy actually for this 1.5 and for the probability is in 1. Okay, yeah, I hope you guys understood the entropy, how we are calculating the entropy for the split, right? Okay, let's see the question 4. So what do you think, what is the correct option for this question? Is anyone? What could be the correct option? See, okay, let me read the question first. If a decision tree is expressed as a set of logical rules, the logical rules we have discussed, right? So how we have designed a tree, and based on this designed a tree we have written there sorry, logical trees there, right? So if the internal nodes are there, then we are adding a and, then if it is goes out another branch, then that is an or operation. Okay, the internal nodes in branch are connected by and the branches by, right? Internal nodes are internal nodes in branch. So what exactly means of this meaning of this question is that, so these are the two branches, right? So if it is considering this single branch, there is an another node is there. This is node A, B, and it is an two nodes are there, C, D. So if you wanted it to follow this path, then we have to do a and operation in between these two internal nodes. These are the internal nodes. Okay. And if you are following only this along with this path, then there is an or operation. So what the previous example, let's take that previous example and try to uh, write here. I'm only taking a sample example here. That is an, suppose this is an studied, or it is true, and then all we are getting is an true and zero fall, zero failed. Okay. If it is fail, then there is an GPA we have considered low GPA. Low GPA, they are fail. Let's take this simple example. Okay, fail. Fail 3 and passed 0. Okay, it's an example I have taken here. So how we are writing this in a logical rules. So if studied S is equal to studied is exactly equal to a fail, and because we fail means we are going to this direction right now, right? And along with this fail or false, study is equal to false, and GPA G is equal to low, then what is the label? Then it is an fail. Fail. Okay, so this we have done right now, right? It is fail. It is fail here. failed. Okay, so another condition, if, right, so the branches are connected, or, so let's take as an or, how we can consider the or here, right? If,
Like in the beginning, it could be a false or a true in the first step.
no, at a time both the options are not there, right? If it is goes to this,
Or is for like as we went for s equals to f. So we can also go for s equals to true. So that is or where we choose between the branches.
right, 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 yeah, right, 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 it is right. So it is saying that, so and means we are considered both together, this and this, right? That is you are saying, right? So if s, here we have to choose in between these two values, s is equal to fail, and or, we are not considering or here, between this only two condition, s is equal to true. So based on this we have to consider, if this will be comes to the before of this statement actually. So this condition will comes at the starting, then it is right. So first, uh, if s is equal to, false, or true, s is equal to true, right? Then then right here, where the options is, then what we have to do, we have to check s is equal to f, and means there here if is also there, then if, right, then if, and if s is equal to f, g is equal to low, then it is false, then it is fail, right? Here this if statement end here, end if, then about this if, then it is, uh, then it is, what we can say, then it is, just let me clear this here, here, and it is then, uh, it is true, and end if here. So what do you think, it is correct or not? Maybe it is little difficult to understand my writing here, maybe, right? So here you can see the first option is, and we have checked that is an yes is equal to fail or not, false or not, true. If it is both from this option, suppose we are going to this option, past this option, then we have to check if it is yes is false or not. So in between this, may can be this option be true, can be this option be true, both together can be true, right? Because we have put it or here. See, suppose the s is exactly equal to f, then we are also checking g is equal to low or not. If g is equal to low, then we are directly labeling it as an f, that is an failed, right? So then we are ended here if statement, this if statement, then we have labeled with the t. So t with means, because this statement is wrong, this statement is not true, we have checking with the only s is equal to 2, so then only the t is here, right? So yeah, this is how we are writing a logical rules. So in the next question as well, this question will comes, but let it be. It's fine to understand the this concept along with the question. Yeah. So here the internal nodes in the branches are connected by and the branches by the or operation, right? So here the option is C option is correct. Yeah. So the same question here there. So what do you think, which option is correct here? So this is the question here, decision tree. So in previous question, is there any doubt? So in this question, okay, if not, let's move to another question. So here the decision tree corresponding to the following, that is, and here the logical rules has been given. C2 if C2, then if C1, then A3. Okay, let's, if C1, then A3, else A2, and else. So if it is, uh, what we can say, it is an confusing to understand. So you can see here, that is, and the hierarchy of this example, hierarchy of that code has been, logical rule has been written here. If the C2 true, then the C1, we have checked the C1, it is true. The C2 and C1 together true, then it is an A3. Okay, please try to solve yourself and please let me know what could be the answer for this question. So refer this hierarchy. Anyone? Okay, let me start the question. So it is stating that, so there is an listic as in true or C2. If it is true, then goes to the C1. Okay, and C1 is a true, then it is printed as an A3. Otherwise, else it is an false. Else means it is false. A2. Okay, and if then here directly it is an uh, A1, A2, because this is an else and else, and means this is an true and this is an false statement represented here. False. And here A1, A3 is there. Yeah. So let's see. Yeah. So here the is more A1, A3 is there, but here C1 is there. It is wrong. Here C2, because of our root node is an C2. C2, C2. These three options are correct. From these three options, let's see which one is correct. C1, here C1 two times occurred. It is not correct. Here C1, A3, E3 and E2. Right. So this C options correct here. Yeah. I hope you guys understood. Yeah. Okay, let's move to the another question. Yeah. So we have discussed that initial point. So we need to calculate the entropy of the database. Entropy of the database means we need to calculate the entropy of a target label, target label attribute. So here, as already discussed, the GPA and studied, these are the attributes, and the past is an target attribute that we are trying to predict from the decision tree. Right. So our aim is to find the student. These are the object one, object two, object three. The S1, S2, S3 are the passed or fail or not passed. So we have to find the entropy of the past attribute. So here, so please try yourself first, then I will try to um, explain it after. Okay, otherwise I will go ahead. Yeah. So yeah. So how we are calculating the entropy? The entropy we have already discussed. That is an S is equal to uh, probability minus probability of the true log to the base 2 is an probability of the T. It's true class. Right. minus probability of false class log to the base 2 probability of the false. Right? So here we are calculating entropy for the past attribute. So the probability of t means true, it is a 1, 2, 3, 4, right? 4 divided by 6, right? Log to the base 2, which is and 4 divided by 6 minus 2 divided by 6 log to the base 2, 2 divided by 6. So what is the answer for this equation? Yes, anyone? Yes. So yeah. So after calculating, you can see 2 point is my sorry 4. So you can calculate it and you so this is in fraction, and so after calculating you will get something about 98182 something like this. So you can calculate on using any calculator or any programming as well. So what could be the nearest value which is near to the 0.92 of this? Yes. So might be you guys understood that, right? It's very straightforward. Yeah. Is there any doubt? Okay. Okay. So this one is then the last question. So here we need to which attribute would information gain choose as the root of the tree. So we already discussed how we can choose a attribute at the first. So based on the information gain, right? So we have to calculate the information gain. So the already Dr. Pavitra has mentioned the information gain, how we can calculate it by using the entropy. The same we are trying to calculate the information gain Ig all samples for the attribute of the GPA. For the GPA first we will calculate it, right? So for the what is the formula for this information gain, which is an entropy of GPA minus summation of values of GPA means categories, right? For this all the splits, what is their sample values from the total value? We will discuss about this, each of these terms will discuss in detail here. Okay, into entropy of S values. S values means these categories are. Okay. Yeah. So let's calculate the entropy for first for the GPA. So how the entropy we are calculating? So GPA, if we are splitting the GPA, so what is the total number of past and failed are there? Past and past, sorry, failed and past, which is the 1, 2 are there, 2F and 4 true, right? These are the, and for the split, let's take the for the split how much we are getting. So for the low, medium and high, so for low we are getting 1F 1T, and for medium 1F and 1T. For high we are getting as an 2T and 0F, right? Are you getting? So GPA, which has an total 2F and 4T, and these are after splitting by using the L, we are getting an 1F 1T, and by splitting by the M we are getting 1F 1T. By splitting by high, then we are getting an 2T and 0F, right? Consider, Oh, previous question. So the previous question here, so here in the previous question, we are trying to find what is the entropy of the database. So entropy of the database we are calculating as an um, uh, calculating the entropy of a target attribute. So here the target attribute is an past attribute. Okay. So considering this past attribute, we have to find their attribute entropy. So what is the entropy formula here? That is same we have discussed here. The probability of the true into the log of the probability true minus the uh, probability of the f into the log to the base 2, which is an for the f. So we are just only putting the values. You can put the values, uh, the probability, how the probability true we are calculated. We have a 4 true are there here. You can see the true r is equal to 4 in the past, and the f are the 2, right? So the probability of the t we have calculated, which is and how much uh, t occurrences are there, and divided by total number of samples. 4 divided by 6 and 2 divided by 6, right? Yes. Have you understood, Palak? Hello. Oh, fifth. Okay, yeah, fifth. So yeah, similar way. So this if, when this if will be satisfied, right? Because this is very straightforward question. I will solve it again. No issue. Forget about the options here. Only see this code here. This is logical rules are there. Okay. So here, if C2, if C2 when this part is executed, when the C2 is true, right? When the C2 is true, and when this part is executed, when the C2 is false. C2 is false, right? That this is a fundamental concept that we know, right? If so, we have drawn because the C2 comes first. That's why we have considered the C2 first in the root node. Okay, one second. C2 first. Then we have a if else means that is a true and false conditions are there. We are dealing with the only true and false. If it is true, then the content in the if statement that is executed, this one is executed, right? So these two branches are there. If it is true, then C1 is executed here. You can see C1 is executed, right? And if C1 is a true, right? C1 is a true, then only this part is implemented. If C1 is false, then only this is printed, right? So the C1 is true, A3 is there printed, and if C1 is false, right? False means this, because it false then comes to the else part, right? This condition is false, then it comes to the else part. So then if C1 is false, then E2 is printed, right? So this part we have implemented right now. Then in this if is already done, right? Suppose this C2, right now we have checked the C2 for the true. If the C2 true, then this all this executed. If the C2 is false, then this comes into the this statement. If C2 is false, then A1, A2, A1 and A3 is printed. A1 and A3 is printed. Understood? Hmm. Where we are. So here we have splitted a GPA in three categories, right? So maybe I think it is clear, right? It is not confusing that much. Yeah, right. So GPA has a how much the total category values are there. The two total false are there in the past attributes, and four uh, total true attributes in the. If the GPA considered only the low category, then we are getting only one F, one T, and only considering the M, then we are getting one and one F and one T. If we are considering H high GPA, then we are getting an 2T and 0F. So considering this metadata, we need to calculate the entropy of GPA, and means we need to calculate the information gain for the GPA. Let me write it again. So low, medium, and high. Then we are getting one T, one true, one false here, one true, one false here, two true, one zero false here. Right. So this is for GPA. GPA. So we have to calculate it, the information gain. First, we have to calculate the information gain of samples of GPA is equal to entropy of GPA minus summation of all values belongs to L, and this value divided, so is into entropy of uh, S value. Okay, so first we have to calculate the entropy of GPA. How we are calculating the GPA value? That same formula, that is in uh, P minus PT. I'm writing one time only here. One PT log to the base 2 PT minus PF log to the base 2 PF. Right. So then minus how much we are getting true, the 4 and 2. So 4 and 2, okay, the 4 divided by 6 log minus log, okay, minus log to the base 2, and then 2 divided by 6 log to the base 2 divided by 6. We have already calculated this in previous question, which is about the entropy of the class, right? That's the same values we are getting here, right? So which is about the 0.92 entropy of GPA, right? Then we have to calculate the uh, so for each split we have to calculate their entropy. This is each split, right? So for entropy of S1, we are calculating the entropy, which is an uh, S. Yes, answer.
So regarding the first part where we are
Hmm.
calculating the entropy, uh, so what is that value like? Like again, we are dependent on the target variable we had. So
Right,
entropy for anyone will be same.
right. Yes, we have to decide the target values here. Based on the target values, we are calculating how many GP has target values. The same values we are getting for that actually for the entropy.
Okay, like so we are calling it by different names all the time, like entropy of GPA or entropy of studied or entropy of failed or not. So,
Yeah, for sample we are only tagging that GPA actually, but that value is the same. We can say that, right?
okay.
So then for the entropy of S1 for each split, we are getting as an log log 1 divided by 2 here. So S1 you are getting right. For the two value we have one F, one T and one F, right? So 1 divided by 2 and log to the base 1 divided by 2 minus 1 divided by 2 log 2. This is an 50-50%. So might be you guys know about what could be the answer for this, right? 50-50% split. So what is the answer? It is n point 0.5, right? Right. Sorry, 1. Entropy is 1 at that time.
One. Yes, sir.
Right. So 3, then entropy for the split 2, we are getting the 1. Right. Same we have calculated because you can see values are the same 1T, 1F. Right. Then for fourth one, which is about the entropy of S3, which is an 2, that is a pure split, which is we are getting as a 0.
Zero. Mm.
So here, how these values are we are putting here, which is an in the IG information gain for the GPA, because information gain, yeah, entropy GPA is it's same, but GPA and entropy and information gain is different for different attribute actually. For studied, you will get a information gain a different. Right? So for GPA, information gain is in 0.92 minus summation of. So here we are doing summation. So this S value represents how many values are comes into this split actually. Only two values are coming here, right? Out of 4 and 2, 6. Out of 6 values, only two values are coming to this split. So those are these values actually. So the 2 divided by 6, like this. Okay. So into uh, what we can say. Oh, right, right. So into uh, what exactly I lost actually. Here we are. Right. The entropy of the S1 here we have to put that is n 1, right? Plus here also two values comes into this. So are you getting the how 6 we are getting, how 2 are getting here? So 2 divided by 6, because only after splitting by m only two records are getting from here actually, right? 2 divided by 6 into that is 1, and plus is let's take as in 2t, 2 is in directly 0, right? 0.92 minus, so, so 1 divided by 3. So yeah, so you can calculate as and 1 divided by 3 divided by 1 plus 1 divided by 3, which is about, let's take as an 1 divided by 3 and minus point 0.92. And about the, so after calculating this, you will get about the 0.2533. 0.25. This is an information gauge for the GPA. Okay. So this we have calculated for the one attribute. Can you please calculate for the another attribute that is studied? So we need to calculate for each of the attribute, and based on that, which attribute has an higher information gain. Based on that, we need to select that to as a root node actually to split the firstly. Right? Yes, can anyone please try to everyone to calculate it yourself. I hope you guys understood the overall things here. Please try to calculate for the studied one information gain. You may write this table and you can refer these equations as well if you want. Yes, anyone? Yes. Has anyone calculated it? Or should I needs to calculate it? So here already the information gain is same for that, right? So this value 192. Then you have to only calculate this S1 and S2 only. Sorry. So the split could be the split of studied, which is an true and false, right? Here true and false are there. Here four true and two false are there. And here for true, how many split is there? True one. For true one, two, three, one, 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 three, zero. Three true and zero F here is there. And here
2F1T.
2F one T, 2F one T. So the here the entropy is
Left.
one already. So how much information gain have you calculated? Not this one F1. One one this one needs to calculate it.
Left one, it would be zero, no?
The entropy is zero, right? Split one is zero.
Hmm.
So the two F
1/3 log 1/3 or
number three. Okay, one second. I need to erase some part.
with 1/3 we need to multiply it with that particular entropy. 1/3 log 1/3 plus 2 by sorry.
That is one T, no, one T. Or
With 1/3 we need to multiply the entropy for that node also, na?
one F. Okay, two F and two F.
2F1.
So you what you said?
First, like
One by three.
0.92 minus this part entropy. So 1/2 log 1/3 and 2/3 log 2/3. So this value should be multiplied by 1/3 overall,
Ah,
which we will subtract from 0.92.
This is a 1 and 3, right? The value we are getting from it is an 0.811, na? Right? Entropy over 3. So, yeah. So, where I will create a new page here, maybe. So we have got as an information gain for the study 1 is equal to 0.92 minus is an uh, how much split we are getting here. It is 3 out of 6. 3 out of 6. 3 divided by 2 into it is a 0. That is already 0 plus how much it is getting 3. 3 divided by uh, 3 divided by how much? 0.811. 811 you got, na? 811 entropy we will get from that. So how much we are getting here? That is, and this one is 0. 0 and 1 into 0.811. So out 2, 3 divided by. So why 3? Okay, it's not about 3. It's 4. 4 plus 2, 6. It is 6. 3 divided by 6. Right. So we are getting as in 0.5145. So this is same values you are getting or something different, because this is 6. So here we are getting information gain of GPA and information gain for studied is equal to 0.5145 and 0.2533. So obviously you can see the information gain we are getting higher from the studied attribute. So we'll select as a studied attribute here. So option 2 is correct here. So is there any confusion or any doubt, silly doubts you have, or any mistake in the calculation? Please let me know here. Yes, anyone? Please have a look on this. Okay. So this is the last question. So what we did in the last question here, so we wanted to find which attribute is giving higher information gain. That means which attribute we need to consider as a root node, or we need to consider as a first split. Okay. So for finding the hierarchy of the attributes, we need to find the information gain of each of the attributes. So how we are calculating the information gain? That is an uh, entropy of that particular attribute minus the sample values are splitted in that particular branch, divided by sample value splitted in a particular branch and divided by total samples into entropy of this sample, this split. Right? Likewise, we are doing the summation of each of the split, and um, this is how we are finding the information gain. So information gain we will get for the each of the attribute. If the information gain of any attribute is higher, that means that attribute we are considering as a root node, or we are considering to split that particular attribute is firstly. Yes, any doubt? Yes, anyone? If you guys not understood, please let me know.
So one small statement to confirm from the theory. So
Yes.
regarding the information gain and the entropy part. So as we split, we want that the entropy should be reduced, right?
Right, 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 right,
And
right.
so in the same way, we can say the entropy should be reduced, or the information gain should increase.
So, so yeah. So firstly, you may check that what is the purity of the node particularly. Purity, how we are calculating the purity by using the entropy, and if it
Hmm.
is near to zero, that means this is an pure node,
Hmm.
right? So, for but selecting attribute that you have to always calculate the information gain. But that you have said that information gain should be the higher. That means the that node is an we can consider is that means it is providing more information for a specific targeted values, targeted class. And purity, we are only checking that it has been leap, it should be leap node or not.
Hmm.
Repeating, if it is a pure, that is decided to be a leaf node. I mean, it is not pure. We can do a further that is in further branches. We can make it in that, and then we can do these things. Right? That
But
already.
like in abstract view, like as we can relate that regarding to entropy. So entropy is suggesting us that yes, if you have lower entropy, you are going good.
No, lower entropy, it's good, but we want the why we are calculating the entropy, or why we are ensuring that that node is pure or not pure, because that we need to decide that particular node is an leaf node or not. If it is pure, when the entropy is exactly equal to zero,
Yes,
right?
the minimum we can get.
Minimum, but it should not be 0.1, 0.2, right? That value is also minimum, right?
Hmm. Hmm.
It should be a zero, so that we can decide that particular node should be a leaf node. Right.
Okay, but like in many situations, it will happen, na, ki we will not end with the pure node. We have to
Ha,
compromise.
right. We need to compromise that, but you may do a further exploration, like that we found that one T and one F. You can make another branch here based on based on a GP, or we can say, let's take as an you can modify it, that let's take the previous one we have taken a studied, and then GPA, right? Then also you may add here, you got as a 1F and 1T. You may also add that is yes, if it is studied early, if yes, if it is false here, and if it is what we can say, uh, uh, we have if we got as a 1F 1T here, then we will split here by F here and T here, and then we also here add a studied node, that if it is studied true, then it is untrue. Then we will got as an a final label, final pure node, but it is an what we can say, it is an overlearned actually,
Overfitting actually will be.
overfitted, right?
Hmm.
So
Hmm.
that is not best for the generalized task actually. Okay,
Okay,
are you
so
getting what I'm
okay.
saying?
So in short, we want lower entropy and higher information gain for features, and lower entropy for the
Right, right,
nodes, leaf nodes.
right. Leap nodes, it should be a pure node.
Okay.
We try to make as much as possible as a pure node. Right?
Hmm. Like that will be again a different story. Like how much depth we should go to, how much
Yes,
nodes or. Yeah.
yeah. I hope you guys understood. So,
Yes.
if I wanted to also take an uh, a programming task actually, how we can do a program for this decision tree, and how we can exactly visualize the tree in the programming, and then we can take a larger data set, and from this large data set here we have taken only the 6 records, right? So if there are 1000 records, doing manually it is very tedious task, right? So that's I wanted to take an one programming session to do a decision tree classification task, and then after only classification. After doing the classification, try to identify the tree structure, how the function, how the model has been designed a tree for this data. That we have also wanted to say, but there is a we are going out of time. Uh, we'll see somewhere, or we can take a last lecture at the end of the weeks. Means after the 8 week, ninth week, we can take a last session. In that, we can do a demo session, program session. So whatever the algorithms we are covering here, a probability algorithm or association rules, decision tree, their visualization, so that we can do in that lecture. No? Maybe.
Okay. And one more thing, sir, like if you could provide some intuition or insight, like we have this entropy one. At the same time, we have also another concept like that Gini indexing thing.
Right. Gene index, I can also provide that what exactly the formula, I think Dr. Pavitra has provided in their slides.
Mhm.
Maybe use that, only
Like,
needs to put the values here.
like regarding the intuition, sir, like what are the drawbacks or what are some demerits or that we
Okay.
have for what kind of scenarios or situation, which one
Right.
we should go with.
Right, 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 right. Right. Understood. So maybe we can do this in next week at the starting of the session.
Yes, sure, sure.
So in detail, we can discuss it about. Right now we can discuss, but there is an required time actually. So we can take a graph and let's compare about the how the entropy is. Means in entropy we have seen that. So at one entropy we got as an point for uh, 50-50 split, right? And zero, that is the
Maximum
what
one.
we are getting. So for
Hmm.
the Gini impurity or Gini index, how that's graph we are getting it. Like
Yeah.
this way, this we can do the analysis in the next slide of the slide, next session maybe. Okay,
Hmm. Yes, yes, sure.
that's it. Or in between, you have any doubts in the say in the week, or you can write me an mail as well. Okay. Yeah. Or
Okay.
what I can do, maybe I can make a notes of this disadvantage or advantage of this. Right now, you will get as an online all these things when we can do this entropy. Because what I'm thinking, suppose I'm taking this session in the next starting session of the next session, there may be required time, or we are going out of time or not. I don't know. But let's try. Okay. Yeah, we'll
Yeah.
try next session.
Yes, sir, like what will be most suitable, like
Sure,
what
sure, sure.
we will do based on, so that we can have high information again.
Yes, yes. Yeah, is anyone has any doubts? Yeah, if not, then we can end this session.
If you could just put your mail in the chat box.
Yeah. So I have already mentioned in my first slide, but still I will write here. Mm. Okay, thank you. Thanks for joining this meeting. Thank you. Yeah,
Thank
you
you.